Okay, we should be live right now. Let me pull up my stream monitor. Yep, that says I'm live. Cool. This one should also say I'm live. Nice. Okay, so we're back for day 12, which is the last day of Advent of Code, sadly, this year. So yeah, let's get everything ready. Let's tell people that we're streaming. Post it to Twitter and up there. Okay, that's all the bases covered. Okay, sad day, last day of Advent of Code for now. Only 12 this year. I can minimize this one. Boom. And let's see, what am I doing here? I can close this one as well. Let's just kill all the days, close all tabs. Sure. Let's prepare the code for day 12 while people file in. Get some time to get in here. Day 12. Ah, I thought I updated the day 0. I don't need to anymore now, but hey Smap, welcome. Was just getting everything ready. I thought I had a benchmark entry for this one as well, but apparently I forgot. So let's add it here. Okay, so that's at least the code prepared for day 12. So are you sad that it's over, Smap? And how did you fare today? I think I saw you post your code, so I think you completed, right? Was it doable? Was it hard? You have your 24. Okay, well, let's see. I should close this one down, put this away. So yeah, I think we'll just start reading and see how it goes. Day 24. Already messing up and I haven't even started yet. That's great. Day 12. Christmas tree farm. You're almost out of time, but there can't be much left to decorate. Although there are no stairs, elevators, escalators, tunnels, chutes, teleporters, fire poles or conduits here that would take you deeper into the North Pole base, there is a ventilation duct. You jump in. After bumping around for a few minutes, you emerge into a large, well-lit cavern full of Christmas trees. There are a few elves here, frantically decorating before the deadline. They think they'll be able to finish most of the work, but the one thing they're worried about is the presents for all the young elves that live here at the North Pole. It's an ancient tradition to put the presents under the tree, but the elves are worried they won't fit. The presents come in a few standard but very weird shapes. The shapes and the regions into which they need to fit are all measured into standard units. To be aesthetically pleasing, the presents need to be placed into the regions in a way that follows a standardized two-dimensional unit grid. You also can't stack presents, okay? As always, the elves have a summary of the situation, your puzzle input for you. First, it contains a list of the presents' shapes. Second, it contains the size of the region under each tree, and then a list of number of presents for each shape that needs to fit into the region. For example, okay? Okay. Is it zero-based? Yeah, okay. The first section lists a standard present shape. For convenience, each shape starts with its index and a colon, then the shape is displayed visually, where a hashtag is part of the shape and a period is not. The second section lists the regions under the trees. Each line starts with the width and length of the region. 12 by 5 means the region is 12 units wide and 5 units long. The rest of the line describes the presents that need to fit into that region by listing the quantity of each shape of present. 101032 means you need to fit one present with shape index 0, no presents, etc. Yeah, sure, makes sense. Presents can be rotated and flipped as necessary to make them fit in the available space, but they have to always be placed perfectly on the grid. Shapes can't overlap. That is, the hashtag part from two different presents can't go in the same place on the grid. Okay, yeah, but they can't fit together. That is, the period part in the present shape diagram does not block another present from occupying that place on the grid. The elves need to know how many of the regions can fit the presents listed. In the above example, there are 6 unique present shapes and 3 regions that need checking. Okay. After some experimentation, it turns out that you can fit both presents in this region. Here's one way to do it, using A to represent one present and B to represent the other. Okay. Hey Marte, welcome, welcome. In the second region, 12 by 5 is 12 units wide and 5 units long. In that region, you need to try to fit one present with shape index 0, etc. It turns out that these presents can all fit in this region. Here is one way to do it. Again, using different capital letters to represent all required presents. Okay. The third region is the same size as the previous region. The only difference is that this region needs to fit one additional present with shape index 4. Unfortunately, no matter how hard you try, there is no way to fit all of the presents into this region. Okay. So in this example, 2 regions can fit all of the listed presents. Considering the regions beneath each tree and the presents the elf would like to fit into each of them, how many of the regions can fit all of the presents listed? Okay. Okay. Didn't we do this 2-3 years ago? But that was with finding puzzle tiles. This one seems harder. Okay. So I think I might actually do bit masking for the first time, because that seems to be an easy way. I'm just thinking like if I go back to all the things I did before, you might want to I'm thinking something like if you have like one shape. Marta says, I got today's problem spoiled at work. Okay, sorry to hear that. Let's say you have these 2 basic shapes, where this is like a 1 by 1, and this is a 3 by 3. I enjoyed modeling today's problem. Yeah, I'm not sure yet if I will like this or not. But my idea would be to take like the max width and height of each one of these, take the biggest one and then the other one and try to place it on every location around or something. So like you start here. So if this is 2 by 2, you start at -2, -2. And then you search the entire space to an offset of after here, something like this. And then you try every location where it fits, and then you record the resulting space, like the square that it takes. And I'm just wondering if... Hey, welcome, Save It here, welcome. And I'm just thinking, how far do I need to go in combinations to make this efficient? Because you can sort of brute force the best options here, but then again you can rotate and flip it, so there's like at worst 8 different versions. Probably also write something to calculate all the different ways it can exist, because some shapes will just exist in less, because they might have symmetries. This will be a challenge. Because I'm thinking, like, would you just do the brute force approach and just try all of them and then see how they fit together in the best way? To like, let's see, what's the input like? Yeah, I'm afraid of that. Jesus. So this makes the brute forcing harder. I'm just wondering if I could, if you take every unique combo of 2 and then take the result of that and add any new shape and just keep making all the combinations to find the smallest path. I have no clue how I'm going to solve this yet. But let's first write out a parser. So yeah, this will be tough, because I don't have a clear, I have some ideas of what might work, but I don't really know how I'm going to tackle this yet. So yeah, let's see. Input split by there was a thing, and SMAP said that recently it was replace line endings. Replace line endings. Was it an environment thing? No, I don't remember. I mean, I can do this to just strip out any carriage returns from the input there. Actually, I can do that here. Oh, replace line endings. So it's here. And this would be... This should be in line with the Unix one. Hey Lakai, welcome. So this should make sure that my input matches the one downloaded from the server, so that I don't have to worry about it. So now I can do input.split by this would give me all the sections. I can do a string. This. I should probably. No, I already have my code zoomed in. Just my eyes that are getting worse, I think. Smap says it doesn't normally need you to fill the parameter in replace line endings. Okay, I'll just be explicit here. Because you want to say what you want. Like my machine has carriage returns, and I want to keep it in the Unix style that I'll from the download file. So I think I do need this, otherwise it will convert everything. It will try to convert this to Windows style because I'm on Windows, and that's exactly what I don't want. So I think I need to pass in the thing that I do want here. I tried to use the environments.newline, but Eric messed up things sometimes. Okay. No, and I think he always has just the Unix style new lines. And environment.newline, if you're on Windows, will have a carriage return in them as well. I do the opposite. I use environment.newline everywhere. Okay. To me, the Windows version is inferior. There is no actual reason to have the carriage return. It's like a little translation from the typewriter area. So there isn't a single reason why you would want to have it in there. So I know it's my current environment.newline value, but that doesn't mean it's a good one. Boom, 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 boom. So now we have the last one. So how do we split this? So we do string, we can do sections. This would be the last one there. 2 lines. Split by. Martin says \n maybe, but \r may be useful for returning to the same line and overriding whatever's there. Sure, but like in text files, it's not needed. Spam says I'm old enough to remember when we used the new line, new line to just go down a line without returning to position 1. Yeah. I actually use the typewriter, so I use the analog version as well of that. And it's quite cool. Have you ever done it on a typewriter? On a real typewriter with a mechanical one? Do you know how it works? It's pretty ingenious. Like there's a spring-loaded one, and it's like the first thing is like it gives away a little bit with very little resistance. So the first thing you do is a slide unlock so that it locks out of the teeth that's in place, and then it goes all the way to the end and it hits a bump stop, and then you keep pushing and that actually hits into gears that roll it down. So the first thing lets it slide, and then it hits a bump stop, and then you continue pressing, and that motion activates a gear to actually roll the typewriter down. So if you look at it like the mechanics, it's pretty ingenious for something that's very, very old. Smap says, I feel old. Yeah. Using a real typewriter is cool. Like the experience of trying to type too fast for the mechanics to keep up and jamming 2 letters together because they're on metal teeth that all go into, so it's like it fans out, and if you push a letter, there's a metal thing that goes in, and they all hit the same spot basically. So if you would do 2 at the same time, before they would hit the paper, they would jam up. So it's if you haven't used a real typewriter before, it's actually quite nice to experience for once. So I can recommend that. Let's see. We're parsing this thing, so we have this one. We do x.split by, and I use my own split by so that I do this without having to trim it out. And I use my very ugly as. The first one is just that one, which I need to split on the x character as int32 as value tuple. Oh my god, this is getting ugly. I'm curious if anybody would still be able to understand this part. So we do this, and then this, and then it's a key value pair. And then the second one is x.split by ASCII whitespace as int32s. Bloop. Like this, and this would also be as value tuple. This is already a value tuple there. So now we would have a list of, and this would be int width I could use bytes actually, byte with, no, it will complain, never mind, it's int with int height, size, and then we have a list of int occurrences like this. So now we need to do like this to wrap that all around, and then we need to make this last one also have this one around them, so it will cast that one. Let's see. Only assignment. Ah, I need to give it a name. Areas. Because of this. Okay. Let's see. What's the complaint here? The type argument. The type argument cannot be inferred from usage. Why not? This would be a list of int. That's this one. And this one would be this one, and what's the issue here? Do I need to do two lists? No. Oh, I have it one. Two lines for each one of them. But that won't make sense. No, that's not correct. This one would be the value tuple part here. So why doesn't it like this? Okay, just to do some debugging and see what it wants to make out of this, I'm just going to copy it here without these and see what it tries to make out of it when I do var. And it still doesn't like that. Ah, sorry, I still need to remove this one. This one is duplicated from there. So let's use the explicit type here. IEnumerable of, yeah. So what's the issue? Was it the issue that I didn't have a to list there? Okay, I couldn't use the automatic boxing thing there. Okay. So yeah. Okay, so these are the areas. We can put those here and have it parsed there. Now I need to do the other ones, and they need to be skipped. So I would need to do sections. Now, if I could spell, I would write sections 0 and then everything except the last one. And I need to do select X. Like this, because we need to skip the first one there, and then we do dot 2 lines, which is fine, and we need to map that out into a set of I can still do that, it's actually fine. Because this one is string array, sure. So I can do list of string array. Shapes is this. So that's that parsed out. Constgar shape marker is this. Empty marker is, I don't think we'll need it, but I'll record it anyway. And these shapes, we probably want to do more with that. Not quite sure yet what I want to do with it, because we want to be able to rotate it and to flip it and create a bit mask out of it and match it against others with offset. So yeah. Let's do a public record shape. String raw, public shape, string raw, this raw is raw. How do we want to do this? Int public int width. Height. I need to mask this out. For int I is 0. Height actually I need to do this in reverse, and actually I can just do height is raw at length, height 0, decrement height. No. I'm making this too hard. Never mind. This height is 0. This width is 0. Same thing here, just for width. X is 0. Width. Don't want to do this every time, so let's do it like this. This needs to be W increment X. If raw line is raw Y, if line X equals shape marker, if X larger than this dot width, this dot width is X, and like the Python way would be to do just this dot width is math.max x this dot width. Which do you guys prefer, this or this? Saved here says math.max love. To me this feels a bit wrong, but it reads like the thing that I love about this is that the intent is so clear. Yeah. I like it, but I'm still gonna do it this way because this is just my way. But I'm actually contemplating writing the math.max just because the intent you can glean from it is just, it's so clear what you're trying to do. This is also pretty clear, but there's more noise in there than using the math.max. And I actually wonder if the compiler would turn that into something optimized, into an optimized structure that is also just as much or even more efficient than this. But it can be much more efficient than this, but still. Boom, 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 boom. So this maps out the width and the height of the shape. Let's make that a function actually. Int a Actually, you could do like size, right? It's okay, I'll do this. It's okay. Okay. So now I should be able to do this dot width, this dot height equals get shape dimensions, this dot raw. Right. We'll probably use this more than once, but only for when you combine things, and I'm not sure if you want to use this or another thing later on, but let me just write out some stuff that I think we'll need and then get puzzling. Meanwhile, my brain is doing some ideas asynchronously. Because I think we also would like to have this as like a bit mask. The issue with this is also that you want to know at what corner it begins, because if there's no hit, Is there anything in the input where you don't know this yet? Well, the thing is, you will have combinations where you will never, where you won't know this, but oh, that's not bad. Okay. So maybe I don't need this at all. I probably don't need this at all. Let's just skip this. Smap says, it hurts my brain when you break the naming standards, like using lowercase for properties. Yeah, that's like the shape thing. It feels so weird. So it feels more like a local variable instead of a real property, but here, just there you go. Nope. Like this. Let's do some fun. Do I want to do this? Probably need a bigger thing here when you start to combine things, but the shapes are all fairly small, right? Yeah, so as long as you just combine two of them, you should be able to use a byte to just combine these. So my thinking was, if you create this into 3 bytes, and then if you want to know if this one fits next to it, like starting here on the third column, you could just bit shift the values and them, and then like if it's fully 0, it should be fine, right? Yeah, is that the issue? Does it need 0x in front of it? I don't remember. No. Let's go here. 12. Byte A is okay. It's not long enough to be a byte, right? Yeah. Oh, never mind. Yeah, I should just do ends. Was it 2? Or would you do bit converter get? I don't even remember, it's been too long. No, that's not it. I don't remember the thing there. Let's see, there's also something wrong with parsing the 0 period. Okay, let's see, call stack. Okay, let me just go here and make sure that I do this one thing at a time. I don't remember how to what the way was to print out the value in binary anymore. Let's see. So this one didn't work. Oh yeah, there are only two new lines there. Makes sense. Now there are 7 shapes. Wait. I still need to split those. I did it the wrong way around here. Set next statement. So now it should be without that. Yeah, okay. Better. So now we have these areas. At least the parsing there worked. Quick watch. So 0x1010b and 0x0101b. Did I mess something up? Yeah, but no, that would invert it. That's weird. This and should result in 0. Am I crazy? Let me think. What was the thing again? No, I was trying to have like the to have a mismatch and go to 0. No, when you do B, right? Oh, was it 0B? Ah, yeah. I couldn't remember the actual notation. That was the thing that I was struggling with. Yeah, okay. Thought I was losing my mind. Thanks, Smap. I couldn't remember the literal for a binary number. Go figure. I had the B at the end at the start, but that didn't work, so that's why I resorted to the 0x, but x is usually for hex, so yeah. I'm off to a great start, but yeah, thanks. So, yeah, this was my idea, like, okay, as soon as one of them overlap, you won't get a 0 number, so that you can use that easily for intersection. So if you have 0B1100 and 0B0011, that also should work. But if you shift this one over, you'll have a conflict. So that was my idea. Like, okay, if I map every shape into a bit mask, I can then offset them. So like if you have this one twice, this one is not non-zero, but if you shift them over 2, it works. If you shift them over 1, there will be 1 overlap, so that's it. Marta says, it's Friday evening, it's okay to be extra tired. Yeah. So my idea was to convert every... and also, like I had before, this is like, it's half a byte. but it gave me an issue that it was to be too big for a byte, and I didn't catch it because my mind just, yeah, I'm sorry. But yeah, basically bit masking, shifting, and that would let me at least do my comparison. And since they are all only 3, so that was the drawing that I made in the beginning, like my idea. If I turn this each one into 3 bytes, I can then offset them based on the shape and see where they fit together. So I could then calculate like a relative offset of how they would fit together. And I think the input itself, yeah, they're all 3 by 3, so that makes it somewhat easier. Because basically if you, yeah, that should be fine. But now for the tricky part. Let me think. So to go back to this one, we have the parsing. We need to, I want to convert this into a bit mask. And it means for each string line in raw, I'll just do it like that, it's fine. I thought I would make it a property, but it's fine. Let's just make it a public property and then it's okay. In this case, do I need to account for any shapes? I keep thinking I want to make this general, but it might be easier to just make this like the 3 lines by hand, or just an array. But yeah, it's fine. Byte mask is 0. For int I is 0, I smaller than width I. Let's see, we want to make it left aligned probably. Does it matter? No, we can do it right aligned. Yeah, we will just shift them over the way they come. It's fine. Mask if line I equals mask shape marker, mask plus equals 1 shifted over I. And then I need to cast this back to byte because it will complain. But that should be fine because it's only 3. Yield return mask. So this would let us create this one into a bit mask. We can do public like this. So we can do mask is as bit mask. Like this. And now the thing that I really don't remember how to do properly, that's like the rotation. And I hope I still have it somewhere. Yes, okay. Rotate left. Okay. Oh, that's for that one. No. I need to have it for like a full. Like transposing, rotating, flipping, that always breaks my head. Rotate, flip. So I have all. Okay, I used GDI plus there. Okay, never mind. Am I really going to try to write this? Smash says, I have helper from those from previous work. Yeah, I thought I might have had them too, but this is just for this direction thing. And this uses like the flags, and it's weird because you can't do up and down at the same time, but you could use this for like possible directions, so then you could have them, and then I used a bitwise version here, so then you can just, by shifting bits over, you can do that. Smash, I've added so many new grid and link helpers this year. I've barely done any, actually. But actually rotating this, it's oh man, I so am not looking forward to that. And I wonder if it's even easier with these, because you probably don't want to do it with the string, and you just want to do it with the bit mask there. This is so annoying. Let's see. Smap UK says, and my visualizer now works in color in my console solver and my web version as well, with animated playback and history on the web. Nice. Yeah, it's really useful once you start to add colors to your console stuff. I have that for some things that I make, because when you have large pieces of text, to have some things pop out with context, so that you can easily spot it in a sea of data. That becomes easy. Oh man, I'm not loving this already. Public bool intersects shape order. Today looks very pretty. I can imagine. Int offset x is 0, int offset y is 0. Now, how do I want to do this? I'm thinking something like this, which is so then you do int min x is math.min source x over x min y is math.min source y other y. Max x is math.max. Source x other x. Max y is math.max. Source y other y. Okay. So basically what my idea is that you can say, okay, I want to compare this shape transposed this way with the other one transposed that way, so that you have a grid. Let me just, like if you have one shape, and I should probably make this, can I make it bigger? There used to be a size thing, but I don't, oh yeah, it's on the side here. Boop. If you have one shape like this, and one shape like this, why am I doing it like this? No, that's way too big. Let's say you have two shapes, this one and this one. Also, I should make this like very simple shapes, and this one is like just a line. If you would draw them on the same axis, like boom, you would have the green one, and then you would have the blue one here. So what I want to do is to be able to say for the blue one, just do like -1, minus, actually 1, -1, something like that, or 1, 1, and then you would draw the one here, so you would offset them. So this way you would know how to change them. I'm thinking for math, because my indices go down vertical, so this one becomes negative, min y, this axis, and this is positive x. Is that true? No, that's not true, because they will be aligned like this. So boom, 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 boom. I'm trying to figure out my axis system, because you have to do the math relative to what you have, and the bits here, this is the first bit, like this part is the first bit. So if I want to move them one over, I'm already tripping up, and I haven't even done anything yet, so this is gonna be so much fun. Not really though. And then you need to have like the sizes of those as well. So to get like the full dimensions, you also need to have because I'm trying to figure out what my dimensions need to be and how I need to shift everything before I start the masking process. How did you guys do? Because it's pretty hard for me right now. Let's see, if we have a shape like Marta says you could use vector 3D rotation, but since you only need to rotate by 90 degrees, either way your shape is rectangular. Why just create all 4 shapes in memory, small and easy then? Yeah, I'm just like the actual just the rotation, and it makes me David says, I'm getting a one-off answer. Still figuring out why. Good luck, man. Like if this is the shape, and I want to compare it to like that. Come on. I basically want to say like this shape, other. So I want to say source x, y, null, other x, y, 1, 0, probably to shift them over by 1. And then I need to make sure that if I want to shift this over by 1, that means that I have to shift over this one the other way. Oh, hey Steve, welcome. Did you do today already? How did you fare? Kiss Killer, thank you for the follow. Welcome, welcome. How did your advent of code go? Did you find it hard? Because I'm still working out what I'm trying to do, and just the basic steps is already messing with my brain already. So I'm just trying to write something that would do an intersect logic here for the shapes that I have. And basically, when I do this, I should probably translate every let me see. The vertical ones are easy, but the horizontal ones can be a pain, because if I want this one to be shifted over 1, that means I just need to do source minus that one. Steve said, I don't want to spoil anything, but I was getting read to write a whole thing, and then I ran some tests to check some properties of my input and ended up saving me some time. Okay. Yeah. Like the shapes are all fairly okay. But I still want to like get all the combinations and see how they fit and write all that stuff. But like I'm already struggling at the basic idea of just combining them, because I had this idea like, okay, you have two shapes, and then you look at the sizes of them, take the smallest one, and then try to position them with like one box overlap at one of them at every position, and then check with binary bitwise ANDing them to see if there is no overlap, and then record all those options, and then see what the smallest shape is, and then see maybe how you can combine more of them. But yeah, it's a tough one. Also because I'm just already struggling with some things, trying to figure it out, because I wrote this to just bit mask it, but if I want to shift it over a certain amount, I need to be careful. So I wonder if I need to work with my bit mask here and shift it over more so that I can do both ways without an issue. Also because the input is only 3x3 shapes, and you only need to ever check more than a fringe here, because if it doesn't go into a fringe at one point, there's no need to check. So I probably should do that. Just make sure that I always have room to shift them over by 2. So that would make this part a bit easier. So for int y is min y, y smaller equal to max y, increment y. And then we do if I wonder if I actually need to combine them. Because the min values are proper, but the max one also needs to be plus source x plus width plus other dot width plus height plus other dot height. And then I do this. Increment x. And now I need to do if x. I first need to align the y's. Let me think. Byte ours is I minus source y. Smaller than 0, 0, and otherwise we have mask this one. It's so annoying. So we have int r. So we do ry is y minus source y. Or would I combine the, I would add the minus, no, you subtract it, I think. Minus 1 plus, so. Bad Cup says this, hey Bad Cup, nice to see you. Did you complete today? Did you do it all in Dash again? I saw you, I saw a video where you raced somebody, I think from a few days ago. That was nice. Yeah, I'm still at the start. I started, I don't know how long I've been streaming, feels like less than an hour, but who knows. Time takes its own shape when I start streaming. And I wrote a small parser, and now I'm struggling to see how I want to do this. So I decided to make a bit mask out of all the shapes, and then write some code to try and do the intersection. But my plan was to have to take like two shapes, take their sizes, but they're all 3 by 3, so it doesn't matter, and then just start at like a fringe of one overlap, just move them around, do the bitwise ands to see which shapes, which positions work, record that, and then use that to see what the smallest shape is that you can make. And I'm still trying to determine if I want to combine a certain combinations of buttons, and yeah, it will be a thing. And I'm already struggling here, so it's this is a toughie, just because I'm already worrying about having to do the rotations and the transpositions, and yeah, not my strongest suit. The pathfinding thing was a bit easier. So yeah, I'm struggling through it, see how far I'll go. So, but I'm still trying to do this math in my head to see if this works. Their y is y minus other y, and I should probably just test this before I move on. But this should then determine which mask I should select. So I do math hours is ry smaller than 0, 0 otherwise mask ry, something like that, and it I forgot I should do 0b. Was it b00? I don't remember. 0b00. It's fine. I'll just do byte 0. Okay. Byte theirs is their y smaller than 0. Byte 0 other.mask there. Okay, something like this, and I should definitely put a breakpoint here to just check it. Return false. This. Steve says, you always have to explicitly cast a literal in those situations. It default will be in. Yeah, but that's why I thought about if I make a if I make like a 5-bit. It doesn't matter. I was like, isn't there a literal for a literal byte value? But maybe byte.0. Nope. Doesn't byte is an I number of t, and that one has a 0, but yeah. Oh yeah, I could do I number byte.0. No, doesn't it like this? Byte 0. No literals for anything smaller than 4 bytes, which often annoys me. Yes. Byte 0. I can do this. I just scream 0 in all caps. Boom, 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 boom. So then we do yes. You need to write your own extension to the compiler to support them. Challenge accepted. So now this becomes, let's see, we need to compare them if there's ours not equal to 0, return false. And we need to do it like this. But this one needs to be shifted over. So let's see if other x larger than 0, no, yeah. If other x is larger than 0, and that would mean we want to shift it to the right. So there's other x. Else, if other x smaller than 0, there's min other x. Like this. And we do the same for rx, no, source x. R's like this. now I should be able to do this. Har Har I says, what are you coding? A big monstrosity. No, I'm actually doing Advent of Code, and it's the final day. If you're not familiar with Advent of Code, it's a yearly programming puzzle that's been running since 2015. You can see previous events and do them as well. It used to be every year had 25 challenges starting on December 1st, like a coding or like an Advent calendar. And there's a programming puzzle that unlocks every day. There are 2 parts to every day, so it starts easy, then gets a twist for part 2, and if you complete them, you can keep moving on. Well, when you complete part 1, you can do part 2, but you can do every day individually. So like if I go back to a different year, I can just go and do day 14 here if I wanted to. And that's a lot of fun. Over 100,000 people do this every year. And this year we only have 12 days, since the creator of Advent of Code spent so much time with it. I think he needs a little break. So we only get a half of Advent this time, a little under half, but it's really fun. Steve says it's my favorite thing on the whole internet, and I agree with that. It's awesome. It's a lot of fun, even though I'm literally like pulling my hair out right now, trying to think of what I need to do for this one. So now we have a challenge. This is our puzzle input. You have the shape of presents, the hashtags are the presents. You have an area designation, and then you have a requirement of how many stuff you need to put in there. So that's this. Aharsa says, sounds ridiculously tough. My conscience goes into coma after solving 3 problem and coding ninjas. This is the last one, so it's really hard. But if you go to day 1, for instance, it had you simulate the dial of a safe, where the logic is there are 100 positions, and when you do a full rotation, you go back to 0. So they had you implement these instructions, and the caveat is that in the actual input there are numbers larger than 100. But yeah, it's fun, and it gets progressively harder. Smap says, the later days are challenging, but the first two-thirds are more fun. Yeah, for sure. So I can really highly recommend it, and just pick a year and start like at day 1, and you'll be able to solve it and have some fun with it. If you code for fun, that is, right? Like lots of people do. Boom. Did I set this one? I need to remove this part here. Also, Smap, do you do this so that you can put emojis in your console app? Ahar says, whenever I see rotation problem, I remember a fast Fourier transform. And Solvit says, I'm not having fun with today's puzzle. Yeah, I'm also struggling already, and I haven't done anything yet, but I will see if this bit works. So I think for my test, I won't even do the part 1. I will just do like var shape a equals new shape. Sure. And I'll just try my I'll just try a simple shape just to test things out. Like this. So if I would offset them 1 to the right and 1 down, they should connect together, I think. No, 2 to the right, right? Yeah. If I shift them over 2 and 1 down, they should fit together if I make 2 of them, which I will just do. Or is that? No, that's fine. So I can do shape a dot intersects shape a, and then 0, 0, and then I want to do x2, y1. Something like this. I think that should be fine. Yeah, let's run this and see if this works. Smash says, I do have a few console-based games using emojis and a whole Unicode playground. Yeah. Okay, let's see. There y is -1. Yeah, so this first one shouldn't have any offsets. Actually, I should have another one here. If ours is 0 and there's this 0, continue. Because there's nothing to match. Steve says Unicode playground sounds like innuendo to me. No good can come of that. Okay. Actually, if this needed to be an OR, so now we compare our first against the second. Nice. I like it. Picasso. Let me set a breakpoint here. Oh. Ah, yeah. Yes. And I need to have the same check here. Okay. Sure, I'll stop. But I think this is actually true. But in this case, our intersection logic worked. Praise be. So, nice. So then if I do the same, but I only shift them over once, it should not. It should intersect. So let me just also do that. Boom, 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 boom. Okay, let me see. Press B. Let me run this. Okay, they worked as expected. Phew, I thought I had a bug there. So that's pretty cool. So the logic works there. Let's see if I do it the other way around, if it also still works, because that, since they are the same shape, it should produce the same results. Let's see, false, true, false, true. Okay, It seems like it works. So that's a first small win. We can take a shape, convert it into a bit mask, and then compare them relative to each other. So that's pretty cool. What is the way to write out a number in binary again in C#? I'm gonna just quickly Google it. C# byte to binary string. Just comma 2. Okay. I forgot about it. No, that's a literal. I meant like it's the. Let's see. I can do it here. So yeah. There's also. So right line. So I can do. Rs to string. No, it was you can do convert to string Rs to. I think that was the one. This is the one that I saw. There's B12 to force 12 bits, for example. Okay. Let's see. Where was my test here? So this should be a quick way to visualize it. And then you need to force the lengths there. So that might be a nicer way to actually write it there. It should be B7 because we have 3 bits padded to over and they can be shifted over once more. I think this one is the one that we want to see. Okay. Yeah, okay. So this one was fine, and then you do here, and then you can see these ones align, so it stops processing. So yeah, it works as expected. Sometimes it's nice to. I like the format string with the B7 the thing. It's nice and convenient. Okay, so let's get rid of all of this. Now the thing that I dread is like rotating and transposing it, and I really wonder. Basically, you need to write a flip and a rotate, and then you can do most of them, but I just don't like it. Public shape flip bool x. Let's see. If x reverse else uh, I mean, this is something that I can do. Return new shape raw dot reverse. And then we do for this one, it will be list string lines. Now I can just do raw.select reverse to array. But this one would give us a char array, so this one needs to be new string. What type is raw string? Yeah, I think it's not the most efficient, but it will save me some headaches to at least have a quick win for the flips. Okay. I could individually, like I could do like mask come on. So you could do like for int I is 0, I smaller 8, increment I, and then do byte new mask is mask. Yeah, sure. Could do mask 0. You could just do this actually. Right? So this one would take, and then we need to shift this over. No. Let me think. Because basically what you want to do is you take mask 0, like you would do this. Like if you wanted to get the last one, this. So this would be like 1, 7, like that. Yeah, I think this would be like this. Right, if you do 0b 01 0 0, and you do this and sorry, and this will be 1 like this. I need to shift them over 2. Never mind. Ah, nah, I'm targeting the wrong one. Let's see. It's 1, 2. So what is the issue? Okay. Okay. So I need to do this and then 2, and then you get 1 to bring it over. But you need to invert it, because basically what you want to do, if this would be an 8th length string, you would do you would do because you need to cross them. I could write it out. I think it's like if I want to do mask this one, and I do and 0b 1 1 2 3 4 5 6 7. I take the last bit and I shift it over 7. And then you would do this one. You shift them over 6. No, actually this would be 5. You need to shift this one over 5. Right? Yeah, because you need to because you need to have like 2 inverse values. So you would have to, for int I is 0, I smaller than 8, increment I. So you would do console, the right line, and you would take I and you move it to 8 minus I. In this case 7 for the index. It's funny how some simple stuff can feel so difficult sometimes. Yeah, this is the thing that I want to do, but then you do this with bit masking. So then you would have like, if we have int, or just like byte test. I mean, tons of small details is always difficult. Yeah. Thanks for the kind words. Let's see. Something like this. If I want to reverse this, you would do byte reversed is 0. So you would do reversed and 1 shifted over I take that bit and then you shift it over. And it depends on whether it's bigger or smaller if you have to shift left or right. So so you do delta, and then you do 7 minus I. Let's see. Minus I. Isn't it this? Yeah, you need to move that one 7, that one 5, that one 3, that one 1. Yeah. Okay. It's 7 minus 2i, basically. Right? Yeah. Because they come to each other, so the difference for each step is 2. Makes sense. So you do int delta is this. If delta larger than 0, we shift to the right. We shift left. Else we shift the other way around. So then you do reversed equals this. Delta. And this would be test, actually, like this. Sure. And otherwise it's shifted the other way around. So now you would say console.writeLine test B8 reversed B8. Didn't work. Why didn't that work? So this one becomes okay. Is line 16 what you intended? I probably messed something up there. I probably reversed these. Yeah, I probably reversed these. Come to think of it. Nope. Wait. When delta is negative, it won't do what you expect. Yeah, I needed to do this one. Sorry, I forgot about that. I forgot to negate the thing. So yeah, it works. I didn't do this one, by the way. Actually didn't check what happens when you do the negative shift right. Does it do it correctly? No. But what matters is that I do it correctly there. I forgot to make it positive again. Thanks for pointing that out. So yeah, this is the basic bit shifting them in reverse. But I wonder if like if this is the most optimal way. So we do a const int bit length is 8. So we do smaller than bit length, and this would be bit length -1, like this. For int, it takes the low 5 bits, so it's never negative as far as the machine is concerned, and it's the low 6 bits for long. When dental is now when it just takes the low 5 bits from delta. Ah, okay. So this should basically work for any value there. So if I change the byte to int, etc. Nightmare says, "Hi, I see we're doing bitty stuff." Yeah. I was just I'm busy doing day 12, and I wrote a shape, and I wrote something to generate a bit mask from that shape, and then I wrote something to do intersects between those bit masks, and I support offsetting them both in the X and Y axis, so you can compare them relative to each other, which I thought was pretty cool. It's probably all overkill what I'm doing, but these are the things that come to mind for me to do this. And I wrote a few tests to make sure that it works, and it does what I expect, so that's nice. And now I was working on the flipping and rotation, and I still keep the raw value, and the only way to construct it now is from a raw. So I was like, okay, let me implement the flipping. And I was like, okay, flipping is nice. It's a nice way to get some of the variations going, because I really hate having to write the rotation stuff, but I still have to do it. But I'm trying to save it for last because I hate it. And then Steve was like, "You're doing it with strings, are you?" Like just a small sneer for, why don't you use the optimized stuff that we already have? And then I was like, okay, let me write something to reverse the bits in a number. And it took me a bit of mental math to figure it out, because I'm familiar with bit shifting and masking, but I just don't do it that often. I really like doing it, so but it takes a little bit of you know. Steve said, "I didn't mean to." No, I'm just teasing you. I know, I'm just teasing you. Don't worry. And I'm stubborn enough to do what I want anyway, so never feel bad for pointing something out or asking a question. Or I felt you could take it, so I was just making a bit of fun. Smap says, "I just did it with grids. I'm lazy." That's fine. But I should probably make a function out of this. Let's do an extension, just because I want to save this code and not delete it. So public byte reverse this byte, no, static public static byte first this byte value. So and let's call this test, and now I can do value. Let's call this result. Um, and then we do a return result. I mean, it's probably far from optimal, but I wrote it myself, so it's fine. Steve says, no worries on my end. I was just worried my intentions might have seemed more negative than I intended. No. It's all clear. It's all clear. So yeah, I could do it like this, and then I should probably make a constructor for the raw thing as well. The only downside is that I would then have to look at the... No, I can make a constructor that just requires that. Public shape byte mask int width int height. Mask is mask, width is width, and height is... So I could do it like this. Like this. And then we do width, height. So I can do that. And now we use our code. So now we can also do this for mask. I mean, this is an IEnumerable, so that should be fine. And then we do width and height. So we don't have the parse step then with the raw. Not that it does a lot of work, but we lose the raw in this case. Not that it matters. I don't think we have to look at that anymore. Do we have references to the raw other than that? The raw? No. Shift F12. No. Just for that one. Okay. Let's see. So we have our shapes. We have an intersection thing. We have a flip. So on the x-axis, otherwise it's on the y-axis. Now we need to have rotation, and I don't like the rotation thing. Especially because it will be a pain to do it with the mask, because I have everything shifted over twice already. Because it becomes like a matrix thing, right? If you want to rotate. Build the test and rotation will be easy. Yeah. Not sure if I want to do this. I actually wonder if I still need to pass. I might still need the raw for this though, because if I take this to explain, let me just create a new one here, because this will become very tricky to rotate. Because what I do is, let's say you have a 3x3 here, and your shape is like this. Blah. That's fine, and then blah. Okay, right? When you have the bytes, I currently turn this into 3 bytes. So 1, 2, 3, 4, 5, 6, 7. And then I take this shape and I place them here in this general area. This is how I make the bit mask. This lets me shift them over if I need to, because I'll never shift more than 2 because of the shape right now. That might bite me in the behind later, but for now it's fine. So if I want to rotate this, I would need to first shift over everything twice. And then, actually, no, not truly. If I take the assumption that it's a 3x3, I can just map them. If you have 4 monitors, you can do them all in parallel. Yeah. Or your SSD. Yeah. I think in this case I might cheat a bit, because the input, that's not the input. Is this the input? Yeah, this is the input. All the shapes are 3x3. So I could just do a hard transpose. Wait. What is, oh no. I think my SSD rotated overnight as my laptop wasn't seeing this morning. Okay. Hack. Our shapes are 3x3 shifted over 2. We will hand remap the values. At least that's what I think. If you rotate too fast, all the bits will fall out. Yeah. So like if I rotate it to the right, like I need to do this, this, this. Basically, this one can stay the same. I think I've written this before, but it just... I'm just trying to think of, is there a... I once wrote like a board game thing that it built itself by just following a certain pattern. I'm trying to think back to that, how I did that, but basically if you keep a direction, you follow it, and if you can't go in that one anymore, you go one at an angle. So that is probably what I need to do. Let me see if I can write this logic. So we can remove this, that was fine. Oh, I will just do it like this. Bum, ba-dum, bum, bum. I'm just thinking, like, this is for the first one. I'm just contemplating just mapping out the indices by itself. Spice says, given your only solid rotation for 3x3 shapes is fairly straightforward. Yeah, I'm just thinking of, like, am I really going to do like mask 0 and 0B 1, 2, 3. We don't care about the first 3. Then we have our shape. So we have 3 values here, and then we have another 2 that we don't care about. So this is the shape of our byte, where these are the ones that we want to target. So then you want to take this one, and like this one becomes shifted over 2 to the right. This is one part. So you would do like byte A, B, C. A is B is C is 0. A equals this. So this one takes this byte and places it here. That's the first one. And it needs to be masked out as well, because like this. Plus, I mean, bloop, and this one would be targeted to this one, but this one then becomes mask 1, and we need to take the left one there as well. And we need to shift it over 1 position. Plus this one. And we don't need to shift it over at all. Like, this is doing it by hand. And it's a bit of a pain, but it's fine. A, B, C. So I use these so that you can see where you target it, but it's like a combination of this plus this shows you which one you're taking, and then based on where it needs to be shifted over. And then you need to take just that value. So this is the first line. To make the second line, you would take, let's see, you would take the bottom row and the middle one there. And you need to shift it left one to target this one. Then you take the actual middle one from there, and you take the top row middle one, top row middle one, and you need to actually shift that over once. I wonder if anybody is following what I'm doing here, because, yeah. Is this clear to people what's happening here? Because like the source for the middle mask byte, the left side of that one, so this byte here, Smap says I'm trying not to follow. Like this is the place that you're trying to set. So B means it's the second row of the mask. We're trying to set the leftmost column, and the source for the leftmost column is the bottom row middle middle figure of the mask. Like if you go here, we're taking this one here, like boop, this one here, and placing it here. That's basically what that transformation does. And this one stays the same, and this one comes from here. And that's what you see here. It's like we target, this is the mapping for the output. So the first value comes from the lowest row middle. The right value comes from the top row middle. And the shift that you need to do is based on where the value needs to be. And then you just take the middle one here. Let's see, for the bottom one, the left one is actually, I think it's the inverse of the top one. So this one becomes 2, this one becomes 0, I think, but let's just do them one by one. The left one for the bottom one is the right one from the source. So this one needs to be like this. So the bottom left digit is coming from the most right, the bottom left bit is coming from the bottom right bit. Amarte says, hey, I got it. I do it for an array approach, but this works too, I guess, and it's faster. Yeah, but if anybody looks at my code, they'll be like, what kind of drugs did he get? What was he thinking? But yeah, you guys said do it by hand, so this is it by hand. Let's see. Shift it over, yeah. We take the right one, we place it in the left one, that is fine. The middle one comes from the middle row on the right, so we need to shift this one from here. This one needs to move to the left by 1. Because we're targeting the middle column. That's correct. This one is correct. So now the rightmost column comes from the top row right. So this one needs to be this one. And then the mask also needs to be this. Yeah. I think this is it. And now I probably need to write out something that will print the shape based on the mask. And I also, okay, you know what? Smap says, this is sort of thing I used to write 40 years ago. Too much time in higher level language these days. Yeah. I don't even need this one. So now I can do new mask is A, B, C. Boom. Throw new not supported except I'm not doing this again in reverse. That Python will rot your brain. Yeah, rotate right. I'm sorry. If you want to do I'm just not gonna. It's fine. I did some Python yesterday when the farmer was replaced at the end of the stream. That was fun. Oh, man. Let's see. Yes, and now I need to do a public IEnumerable string print mask for each byte in mask. I can just do by m shifted over 2 yield return. Oh, this will be so nasty, and I'm already having fun with it. B3 replace 1 print mask. Oh no, it's the shape marker. Okay. Something like this, sure. For int I is 0, I smaller than 4, plus I. Console for each string line in shape b dot mask print mask console that white line fine shape b is shape b dot rotate right. Okay, let's see if my rotation works. It didn't do anything. Cool. Ah. Okay, let's see. I need to do another replace. Okay, let's see. Rotated right. By God, it works. All right. No. Yeah, I think that's correct. I should do it again, and then it should have. Was there ever any doubt? Yeah. Nice. And Steve says, first try. Yeah, I know. That's pretty cool, but why am I still not really happy? Oh, there's still so much to do and I've already been busy so long. I mean, we're making progress, we're getting there. Boom, boom. So now, let me see. Come on. Members named Cone. Copy. Fine. And actually, I need to make sure that I do so. I just want to make sure that the test, that I can actually do the test and that it all still works. Okay. Something like that. Oh. 28, 8, 12. Wait, what? That's interesting. What did I do wrong? $28, 8, 12. 28, 8, 12. Oh, I don't print it anymore. Never mind. Yeah. So this would be the equals. I just don't print out the same shape again. So now it works. Yeah, okay. Because I do it here one more time and then it won't match. So, so we have the flips. I haven't tested the flips actually. For flip B X is shape B flip true. False. Flipped. Then I can do this again. So we can do flip b x dot flip true like this. Same here. Oh. Ah, this needs to be false. Thought I broke something, but no, they both work. Oh, but this is wrong. The y is correct, but the flip x is wrong. Boom, 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 boom. That's an interesting one. And that's probably, let me look at the flip x. So that's my reverse thing here. But the thing is, I need to do, that's annoying as well, because we don't want to reverse that one. We need to shift it one over. Because otherwise it won't be aligned properly. Come on. Like this. I think this is the one that we want. Yep. And this comes back to this part. When we reverse this, we still want it to be two aligned from the right. So if we reverse this, we want to shift it over one to the left, so that when we reverse it, it becomes aligned in the same way. So, and this also, all of this only works because we know that of the shape of the thing. Okay. Let me add a comment there, because I will not remember that if I look at this later. Our masks are 2 from and 3 wide, so when we flip the bits, pre-shift them 1 over, so they are still 2 after flipping. Okay. I mean, it's been really fun to code all of this. It's just like, I really wonder how far along we'll get. It's so tough. So much work. My brain is already fried. We wrote some cool stuff though already, but now I haven't even gotten close to try to solve it yet. I haven't even started the attempts. So now, the end is near. We need to have like a try-fit logic. Steve says it's a little close. What do you mean by a little close? Boom, 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 boom. We have all of this, that's fine. So we do public void try fit shape A, shape B. You have all the building blocks. Yeah. But now I'm getting bored and I'll start eating the crayons, you know. Let's see. For because basically now we need to go try this thing that I came up with and try to see how we can relatively position one around the other and see which ways they fit. So let's just do for int x equals -2 x smaller than 3. Let's just be explicit about our intent. Smaller equal to 2, increment x. Is that actually... We don't care about 0, 0. All the other ones is probably interesting. R intersects B. Got some Python you see that, yeah. 0, 0, x, y. I only need to do one or the other, but this one is fine. If not, like this is all the way around, and then you also need to have all the variations and rotations and flips and oh no, let's first do public list of shape, unique rotations and flips. Like this. Result is new. Blah. No, dictionary long shape. Uniques is blah. Return unique of values. Now unique values. This. It's a finite number of possibilities you can pre-calculate. Yeah, I'm doing that. No worries. We first need to public ulong hash get private set. After setting the bit mask, we do hash equals mask 0, 16 plus mask 1 plus mask. This. I need to expand them first, I think, so that they don't overflow, but it's fine. let's see. Just wait until part 2 where you're no longer on the grid and it's a proper bin packing with arbitrary rotations. Yeah. I think somebody already said that it's just the claim thing for part 2, but yeah. So this is the unique shape put into a hash, which is way too long because we could actually just use a uint. I just thought about because our masks are actually offset. So we can take this one is shifted to right to 2. Because these are the only places where data exists. We can shift those over 1. Oh man, this is so messy, but I like it, I like it. Like this. And this one becomes uint 4. Yeah, I think this is the mask that we need. Because this one is shifted over 2, so that one is that. This one is already shifted over 2, but it needs to be 3, so we shift 1 over more. So that is 6, and then 4, yeah, that should be it. So this is actually the masking logic. And now I'm thinking we could actually just public byte mask from hash uint hash and this would be the first one would be for yeah. Like this. If you make the mask 4 bytes, it's already an int. Yeah, but now I can. It's 3. Actually, this should have been a short. Use short. Because we only need 9 bytes. But yeah, let's see. I was doing this. Let's see, plus isn't defined on anything smaller than int, so you have to cast after addition. Okay. Okay. So now we can also do this. So I think we have all the versions how we want to do this by now. I still need to test this, of course. And then we can do the thing there. So let's see, we have this. So we do u short b hash is shape b dot hash. Shape from hash is new shape b hash shape b dot width shape b dot height. I can probably stop with the width and height by now because we have so many things already saying that it's 3 by 3. So debug.assert from hash of hash equals b hash from hash logic miss hash. Dun, 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 dun. And I should probably do another sequence equal there as well, but okay, that works. Shape b dot mask. So let's run this again. That should have everything tested. Okay. This one also worked in one go, so that is nice. So now we have a way to turn any shape into a 9-bit value. Let's see, what was I doing? Oh yeah, the unique ways here. So we do for int I is 0, I smaller 4, increment I. If not, uniques. Am I writing this wrong? Yeah, I had it wrong. Okay, unique, so it contains key. Oh yeah. Shape. Next is rotate right. Let's just do that. Next hash next. Actually, we can just reconstruct them from the hashes, but that's fine. And then we do next is next at rotate right. Would I do this? You start with the current one. Would that modify? No, it should be fine. Next, yeah. And then you do for int next at flip. We don't really care which way because it does the same thing. And then we do the whole thing again. Let's see. For B variations equals shape B dot like this. My A one was symmetrical, right? Yeah, this one was symmetrical, so that should give way less versions. A, so we do console, the right lines, B variations that count, A variations that counts. Let's see what it says here. B is 4 ways and A is 2 ways. I'm not sure if that is correct. Is that true? Ah, that makes sense. I did it wrong. I didn't assign, so I never overrode it. So yeah, B has 8 ways, A has 2 ways. So I think we've done enough testing. I want to go for each. Smap says time to start work on the problem. Yeah, we've played around enough. What is shape here? Wait, what? Didn't I do the input, prepare input section? Is it sections? Shapes. Ah, I never made them global. So yeah. Okay. Smab says, looks like I saved about 2+ hours by using my existing grip helpers. Felt that one. Let's see, prepare input. Yeah, okay. So I can do the print out of this one. Okay. Let's see. Are there 8 variations for this one? It demands, like if there's one symmetry line, sure. Bit manipulation is cool, but seems overkill unless you are Steve. Okay. Yeah. So, okay, we found our search space, we reduced it a bunch. We should probably build that here to have like a dictionary of use short and then list shape variations. So the prepare input here could then do is shapes to dictionary x dot hash x like this. So now we have everything there. So we have our shapes. Those have a hash that we can use to look up all the shape variations. And then there was I had a function to look at how they would fit together. Try fit, yes, okay. So now let's go to the test input. For the fourth one, okay. We do a manual test here. We don't care about this one. Var shape is shapes. So last one there. So we do shape, try, fit, shape. Var ways is this for each var way and ways. Console, that right line. Okay. Luke says, hi, just returned from Christmas thing. How far are doing? I haven't even started on the real problem yet, but I wrote a whole lot of cool stuff. So to recap, I have a shape that gets constructed from a raw string that can make itself into a bit mask. I have the logic for that. Let's see, as bit mask. I have something to create a hash from the set of bit masks. I can reconstruct the bit mask from the hash. I have logic to rotate the shape based from the bit mask, which is a pain. So I tried, this originally was a rotate with a right and left. And after implementing the right, which worked the first try, by the way, I was like, I'm not going to do this again for a left rotation. This was pretty fun to write, but I think when people look at this, they're like, what is going on? And this abuses the fact that it's a 3x3 shape. I did stuff to flip on a XY Let's see. You're going to pull out your hair when you find out the solution. Yeah, probably, but that is fine. Flipping on both axes, I have a reverse function for a byte. I wrote it here, which was also a bit of a pain to write, but fun. I mean, I like doing stuff with bits, but yeah, it was a lot. Yeah, I wrote stuff to go from a text version to a bit mask. I wrote intersection logic that intersects two bit masks with relative offsets, so you can specify how one should be positioned relative to another, so that you can see if they overlap and use their masks to see if they intersect. I wrote get shape dimensions before I looked at the code, and this is totally unneeded, so we just hide it and pretend like we didn't write that. I have something to go from a mask into a string representation for visualization. I wrote something to calculate all the unique rotations and flips for each shape. And then this is my brute force, try to fit every relative position and see how they connect. And I was just about to go and run that. So this is the test. I parsed it out. I get all the variations, so you can see 8, 8, 2 of those, 4 of those, etc. So based on how their symmetry works, this is symmetric on 2 axes, so you only have 2 variations. This is only symmetry on 1 axis, so it has 4 variations. This one is on 2 axes, well, diagonal. So yeah. So now I'm going to try to see how the simple one can connect to each other. And this is basically an offset. So when you, let me just write this one out. So if you see 2, 1, that means you have one shape here, and the other one is shifted 2 over and 1 down, and then it does this probably. Let's see, did you check the real input to see if the size of the shapes is also 3 by 3? Yes, all the shapes are 3 by 3. I checked the input. Otherwise I wouldn't have done all of this. I would have to do something else. But no, the inputs are all 3 by 3 here. Unless there's a surprise here, but no. All 3 by 3. Okay. Are there inputs where they're not all 3 by 3? But yeah, so the thing that I wonder now is I take this shape, and it says when I shift them 2 over, 1 down, they fit, but it shouldn't probably. Right? I should probably, because that doesn't look right. So let me write out that shape. Ah, no, okay, it's the wrong one. I looked at the wrong one. Wait. This shape, 71. Is that the last one here? Oh, okay. I needed this one. See, it has no ways to do that unless you go and try all the variations. So that's what we need to do now in this try fit. So we have, that's what they show in the first example. Yeah, I know. I just need to make sure that I get all the variations first. I was getting there. A dot, so I can do actually the shape variations, yes. Var variations, A is shape variations, A dot hash. I can't access that from here. Sure. Probably just want to have an overload for that. For each shape A, for each shape, I should probably get the unique combinations of those actually. No. Who cares? I could do a because there can be dupes in this combination as well, and you don't want to do more work than you need to do. Public static IEnumerable shape A, shape B, get unique combos. It's such a hassle, but it's fine. So we do for each shape X in A, and B, hash set ulong scene is this, ulong key is x dot hash 16. Actually, we don't. This can be a uint. I'm just gonna do it like this, plus y dot hash. Yes. I need to do this before, or it will be shifting away. So this is a compound key there. If not seen contains key scene dot add key yield return. This also needs to be sorted. Ba-dum-bum-bum. If x dot hash larger than y dot hash blah, otherwise inverted. Public static uint combine hashes u short a, u short b, a larger than b, uint a. This is what I hate. It's so unreadable. It shouldn't do this. 16 plus b. And the ordering here doesn't matter at all as long as it's consistent. So this is an ordered key. Like this. So now we have a unique key for a combo. Yes, and then we'll return A, B. We don't have to care about the order in which we return these. So, boom, 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 boom. So now we do for each pair in get unique combos A, B. That's what to show. Okay. My Twitch chat just disconnected. I think I've been streaming for too long. Let's see. For each var way in try fit pair dot A pair dot B yield return way. Okay. Christ. Oh, yours disconnected too. Okay. We should probably distinct this as well. Even though it shouldn't matter. Okay, so now we can do here. Try fit, and this would then be variations, shape variations based this dot hash. Okay, so. Oh, you're special, Smap. Let's see. Okay, so we have these two, and these are the ways that they can interconnect, which is great. The only issue that I have is once I do this, trying to fit more no longer works. I can't test how something fits on anything larger than a 3x3 shape. Now that I think of it. So this was a pretty useless exercise. Because if I take like one of these and then combine them, the total number like the absolute value combination of these shows you the new shape. So by using this one, I can make it into a 4x4 and fit those two in there. So now I'm wondering, like, if you do how 5 goes into 3, that's interesting. That's a very optimal way to do it. So I wonder if I should try every one of these and then see how they fit. Ah, and this one fits into this. there's like relationships between them, 0 and 2. So these together fit really well. Like you can fit for every one of these, you can fit 2 of these into a perfect square. Is this the thing that I was supposed to see? Let me see. Is the same thing happening here? Yeah, this one connecting to this one. Probably. This one connecting to this end. Mm. Oh wait, there's actually something else that you could do that's cool. Um, because if you take this one and combine it with like there are probably ways where you can just take this one, like this one can be on top of this one, so you could just remove this one, add them to this one, and this one becomes a 3x2 shape whenever you can do that. So whenever you have 1 and 2 together, for the min of those two, you can just treat this one as a 3x2 and this one as like this thing not being there and just having a gap here. And then you have 6 left. I wonder if something like that is the actual like input focused way to solve it. Because this one, if you flip and rotate it, you can connect it to this one. Then you have one open spot here. These only work well with each other. So if there's an even number, they'll be connected like that, and you have open ends there. My only problem is that I can solve this one and then it pretty much ends. Let's see. I didn't think of how to tackle that bit, because basically you want to merge away and then currently everything I've done is quite focused on having like a 3x3 shape, so after that I get into trouble because of some of the shortcuts that I took. So yeah. I mean, my code solves this right now, so that's something. Because basically this way of relative positioning and this way, these all work to make it a 4x4 shape. I just wonder if I need to do something to create like new shapes out of the remainders. Because one thing that I'm thinking about like is what if you would just Oh, that would also add constraints there. Oh, there's none that combines these two in the test input. That's a shame. Don't think I even put in the test value here. So close yet so far away, right? I've written so much cool stuff, but it's no way near close enough to solve this problem. Because the next hurdle that I need to tackle is how it works together as a larger shape. Because like when I look at the inputs, if you combine some of these, like I said, what was it? Like this is a perfect example for like shape 3 and 5. You can just connect one on either side. So if you have 2 3s and a 5, it would make a perfect square, a rectangle shape without gaps. So you could combine new shapes from those. And that's like what I need to do here. I would have to combine those shapes, but my code can only handle simple 3x3 shapes. So that's a major shortcoming of what I wrote. And that's not very bueno. Bit of a shame, because I really like the stuff that I've written so far. It's pretty cool, I think, but it doesn't get me to the finish line there. And I don't think there's an easy fix for that. So it's a shame that like everything I wrote works. Steve says it looks like the largest target dimension in your input are 2 digits. Not sure what you mean. Yeah. But I'm just thinking, like, if I would the issue, like, I can find the best way to put 2 shapes together and get the smallest size, right? That's not the issue. The issue becomes when you have to do more than that, because my code just can't handle that without maybe going back to a string and then slicing up a 3 by 3 shape and then cutting that off. And so I don't think this is gonna work, and I don't think I have the energy to start over right now. Mm. So if you wanted to, you could make a grid out of U-longs since they appear to be long enough. Yeah, sure, but that doesn't mean that I then have logic to rotate all the stuff and I think I'm going to save this one for later because I have to think of a whole new approach, which is a pain. Luke says, if you want a small hint, just ask. No, I don't need any hints. Um, I thought of an approach, and I was very short-sighted in how to solve it because I can't do more than compare two 3 by 3 blocks, um, and that just won't do. So this just means end of code isn't over for me yet. Day 12 didn't finish part 1. I'm gonna commit this, send it over. I just realized that I don't have my extension there. Steve says, I can hear Eric laughing maniacal. How do you say that? Maniacally? Maniacally?
Maniacally.
Maniacally. Yeah, sure. That makes sense. Maniacally. Yeah. Sure. I already see like bits and pieces in the Discord, but yeah, I have no clue what it's about. So it's a shame because I really like what I've done so far, but I also know that I can't go further from here, and I don't see the obvious gotcha that should be here. The only thing that I can tell is like if you rotate and flip this, it fits nicely here, and you have the same for like some other stuff. But yeah. Steve says, I really like what you've done so far too. Well, I'm happy that you like what I did. I'm happy with what I did too, so that's a bit of a shame because it's been a while since I've had to do a bunch of bit shifting and everything works. So it's nice when you envision a solution and it works as expected. It just, my solution was a bit short-sighted. Plus, Matt has been streaming 2.5 hours on day 12 and he's no further than you either. Ah, okay. So I can take solace in that, but yeah. I really, I have to agree with Steve. Like, I really like the stuff that I've written so far, though. It's a bit insane, some of the things, but it works and it's pretty cool. It has a high cool factor for me, at least. And I worked through all of the issues, solved it, tested it. Yeah. Exact cover problems are notoriously NP-complete too. Yeah. I've never had any like formal education on stuff like that. So even like the whole N, O, and it eludes me. But I'm a practical solver. So yeah. Normally I would go over what everybody did right now, but I want to. School is for nerds. Matt says, I like my visualization for this day, but I think if I show you, it might be a spoiler. Probably. On the other hand, I have to admit that I don't know when I will be able to spend, because the things that I'm thinking about right now will take lots of time, and I don't think I will have lots of time to do that. So I'm kind of curious to see what everybody else did. Um, hmm. Luke says it's a one-liner. Yeah, sure. Even glancing at other solutions will be a spoiler. Yeah, I'm sure. But everybody's here now, and I might as well do it. Because I don't think I will take this much further as is right now. And otherwise, this will just end up like one of these. So, I don't know. I'm torn. No. Um, I think what I'll do is just end it for now. Think about what I want to do next, and there will be a stream in the near future. Your chance to get all the stars in the last day, yeah. Yeah, no, I think we'll do that. Let's just find somebody to stream. It's still not that late, so my wife will be happy if I come home at a normal time as well. So I think we'll do that. Let's see if we can raid somebody, spread the joy a little bit, and then I promise there will be another stream soon. Um, let's go say hi to Plasmate, I think. Okay.
Yeah.
So sorry for not finishing today, but I think this is the wise thing to do for now.
Almost okay. Presence is null.
I know, I'm not disappointed. It's fine. I like what I did today. So let's go say hi. Bye bye. I'm glad everybody had fun.
Null. Oh, thank you for the raid, NKCSS.